So part A, want the free body diagram. So draw the block, right? And then FG is there. So point down. And then F friction, right, is moving to the right. So friction will oppose it. And then there's your apply force F, right? Something like that. And then your Fn has to be greater than Fg, right? Because it's both the force down is equal to the force up. So force down is Fg plus Fy, right? Because for this right here, Fy, okay? So that's the free body diagram. And for part B, I'll do it over here. Using the data in the table, indicate below which quantity should be to yield a straight line for acceleration, right? So I see x and t. So we can use the displacement formula to find acceleration. Oops. Vi t plus 1/2 square. And then we know that the box was initially at rest. So your Vi is 0. So this term cancels out to 0, leaving you with right. Then divide both sides by t squared. Right. Leaving you with this equation for acceleration. Right. So that's your equation. And so we know that slope is equal to rise over run, or delta y over delta x. So looking at what we have, this is delta y over delta x, which is y is your vertical axis, right? So your vertical axis is x. Then your horizontal, which is your x, is t squared, okay? And so in the table, we don't have t squared, but we can find it by just squaring of our delta t. So right, which would give you 0.04, 0.261, 0.5476, 0.81, and 1.69. So that is part A and B. Now that we got all we need, we can plug it into the graph. So we know our y vertical is x. So x in meter. Then our horizontal is t squared. And then the unit second square. And then for the scale, oh, the 0.5 each. Okay, so 0.04, and then up 0.36. So right here, and then 0.26, around here. And then 0.5476. Then 0.493. Around here. Then 0.81. Here. And then last point, 0.69, 1.69. And then 1.521. Right here. So the best line would be like that. Okay. So now we will try to use the slope of the best fit line to determine your AX. So first I'll create two lists. So L1 is your X values, okay? So 0.036, 0.234, 0.493, 0.729, 1.521, and your L2 is T square. So 0.04, 0.2601, 0.5476, 0.81, and 1.69. Okay. Then I'll do a linear regression with which is just a best fit line, and it is AX plus B, which is the same as MX plus B. So your A is the slope, right? So earlier I stated that L1 is X and L2 is T squared, right? And we know that our X is the vertical axis and our T squared is the horizontal axis. So I'll just swap these two numbers right here. Right, so there we go. Oops. So this is L1. So your A is your slope, so which is 0.9. Okay, so 0.9. So for part E, we're trying to find an expression to find mu k using Newton's second law, okay? So first I'll do the x-axis, so delta F x, right? So you know it's pushing it to the right, so the force of Fx has to be greater than Fk for it to move to the right, right? So Fx minus Fk is equal to max. And then we know that mu k is equal to fk over fn. I can just move this over. So fk is equal to mu k fn, right? Which is what we're trying to find. So now I'll expand on everything. So fx is adjacent to theta, so that's f cosine theta minus mu k fn is equal to m. So, but we don't know what fn is, so that's in the vertical axis. So let's try to find it. Let's separate this so it's easier to look at. So now second law in the vertical axis. Right. The block is not flying off anywhere. So your ay is 0. So this whole term cancels out to be 0. So, and then we know that up is equal to down. So fn has to be greater than fg plus fy, right? So I'll write down fn first because it's greater. Fg minus fy is equal to 0. Then I'll move everything over, just leaving me with fn. Right? Then I'll expand on it. So fg is just the weight, which is mg, plus fy right here. Is opposite from theta. So f sine theta. Okay. Oops. This is supposed to be fn. Okay, so you get that equation. So now I'll plug it in. So f cosine theta minus mu k parenthesis mg plus f sine theta is equal to mas. Right? And then now I'll try to isolate for mu k by swapping these two. So f cosine theta minus mas is equal to mu k right? Then divide both sides by the parenthesis. Leaving me with this final equation to find mu k. Right. So it's in term of f, m, g, theta, and as. So there we go. And now for part F, it wants us to find fk given off those values. So part F, right? So earlier in part E, we know, okay, I'll write it. So net force in the horizontal axis, right? I'll expand on it. So fx minus fk is equal to mas, right? So we're trying to find fk. So I'll swap these two to isolate for fk. Then fx is just adjacent to theta, so that's just f cosine theta. So fk is equal to f cosine theta minus mas, right? So now I'll plug in the number. So I'll just rewrite the values. Okay. There. So I'll plug it in. And earlier, we found AX to be 1.8, right? Which would give us 2.4 Newton pointing to the left, right? Because it's moving to the right, so FK has to oppose it by pointing to the left. So that's part F. For part G, it wants us to calculate mu K. So we know that mu K is equal to Fk over Fn, right? And then in the last problem, we found Fk to be 2.4 Newton, because we can use it because we're using the same values as in part F. So 2.4 all over then Fn, and then we learn in part E that Fn is equal to mg plus f sine theta, right? So mg plus f sine theta, right? So we have this equation for mu k. And then I'll plug in all the values we're given. So 9.8 plus 12 sine of 60, which give us 2.4 over 29.99, which is around 0.08. So that's your mu k. And then for part H, it wants us to justify if decreasing the angle will do what to your acceleration, right? So let me copy this equation for AX. Wait, I'll just move it so it's faster. So part H we have this equation, right? I'll just divide both sides by m. So these two cancel out, leaving me with right. And then we know that Fn is mg plus f sine theta. So I'll replace that. Okay. So when we decrease theta, your cosine values will increase and your sine values will decrease, right? So by that logic, when decreasing the angle, your Fx, your force of pushing the block to the right will increase, Well, your friction force, which depend on Fy, right, will also depend on Fy, would decrease, right? So if you were to decrease the angle, F cosine would increase, which is the force to push the block to the right, while F sine would decrease, which is the force of friction, therefore increasing your acceleration in the horizontal direction. And then for the last part, I'll just sketch out of the graph. So this one, I want an acceleration versus time graph. So acceleration, which is meter over second square over time, which is a second, right? So I'll label it 0.5, 1, 1.5, 2, and 2.5, then 0.5, 1, 1.5, 2, then 2.5. Right. And then earlier we found the acceleration to be 1.8, right? Positive 1.8. So it will be right here. Oops. Here, positive 1.8. Right. Then next is the velocity versus time graph. So right here, velocity is meter per second, and then time is a second. Then same scale, 0.5, 1, 1.5, 2, 2.5. 2.5, right? And then it would look like this. Up a bit, cause right. So it's a linear line, and the slope of this line would be positive 1.8, right? Meter per second square. That's the slope of the line. Okay. Then lastly, I want the position versus time graph. So X, right, meter, then T, second, right? And then since your acceleration, your second derivative is positive, is concave up, and then your velocity is increasing, so it's the right hand side of the concave graph. So your position graph should look something like this. And that's it.